Today, I'm going to explain the torque slip characteristics of three-phase induction motor. For that, we must know the expression of the torque of three-phase induction motor. So here I can express it as torque is equal to T is equal to K phi S E2 R2 by R2 square plus S X2 square. So K is the constant of proportionality, phi is the flux per pole, and S is the slip, E2 is the rotor EMF, and R2 is the rotor resistance. So in this equation, if I put S is equal to 0, then torque is naturally is equal to 0. So if we draw the torque slip characteristic curve, so it will start from the origin. So I am now drawing it. So in the y-axis, this one is the torque, and the x-axis, this is slip. So from slip S is equal to 0 to slip S is equal to 1, we have the normal operating range. So torque is proportional to slip from OA in the OA region. When slip is very small but not equal to 0, then what will happen? The denominator Sx2 square will be very less. It will be very small. So what we can see, when the slip is very small, at that moment rotor speed is close to the synchronous speed. Because S is equal to ns minus an by ns. And the term Sx2 is very small and negligible. So we can rewrite the torque equation. So here we can neglect the Sx2 portion. Right, as it is very small. So here we can see the low slip region. So now the K, phi, E2, R2, these are all constant. So I can write torque is proportional to slip. So torque is equal to K dash S. So this one is our equation of the straight line. So if you see the graph, the initial region from 0 to A is a straight line passing to the origin. So whenever you draw the torque slip characteristics, be careful. Initial portion is a straight line OA. Now next we have to consider the other thing. Initial portion is a straight line. Now if the load on the motor is increases, what will happen? If the load is increases, so naturally the speed of the motor will be decreased. Under such condition, the slip will be very large compared to R2. So now we can neglect R2 square. So we can write the torque equation again. Torque is equal to K phi S E2 R2 by R2 square plus S X2 whole square. So we will neglect R2. So it will be K phi S E2 by S X2 square. So as in the numerator there is S and in the denominator there is S square. So 1 upon S is there. So other things are constant, K phi E2 R2. So I can write torque is proportional to 1 upon S, inversely proportional. So when slip increases, torque decreases. So if you found this helpful, give it a thumbs up, subscribe for more electrical machine topics and drop a comments. Which part was confusing? Maximum torque location? See you in the next video. Thank you very much. Take care. Best of luck for the exams.